Hello everyone, back again. This time we're talking about, still kind of talking about comparing numbers, but this time we're going to do them on a number line. Basically be able to put these numbers on a number line in order, okay? So when we look at this, okay, so we're going to graph find numbers on a number line. Basically what we need to do is be able to find, first of all, what spots they fit into and kind of estimate where they're going to go, okay? So for example, -2 here, that's a pretty easy one to put on the number line because it is an integer. -2, oh look, I can see there's a spot right there, -2. I'll put a point right there and I'll label it as -2. So there's my first number on the number line. Some of these other ones are going to require a little bit more work on my end though. For example, the 5 2/3. So this one's done. The 5 2/3, well, 2/3, if I want to think about it, I can kind of think, all right, well, here's 5 and what's 2/3 away from that? Another thing that you can do is you can convert into a decimal and then think about the decimal. Well, for 2/3, that would be 0.66. Repeating, so I can kind of go out to 0.6 and put a point there, okay? So what I'm going to do is I'll go to 5, I'll go out about 2/3, I'll put a point down, and I'll label that as 5 2/3. We're going to hold off on the negative square root of 5 for 1 second. We'll come back to that one. Let's go ahead and do this one, 5.67 repeating. Now, this is where being able to compare the numbers together will allow us to put them on this number line a little bit more accurately because 5 2/3 and 5.67 repeating are very close to each other. If I turn this into a decimal, it'd be 5.6 repeating, or 5.66, okay? So this one is slightly smaller than this one, but not by much, by like 0.011111, okay? So if I go to put this on the number line, I need to put a point basically almost overlapping it, but just slightly above where I put the other one. I'll put the label down here, but that's going to be 5.67 repeating. And last but not least, we have negative the square root of 5. Again, I want to try to estimate that by thinking about my perfect squares. The square root of 5 is going to fall in between two perfect squares. That would be 4 and 9. And the square root of those numbers is 2 and 3. Okay, so this falls in between the square root of 4 and 9, which the square roots are 2 and 3. So we know that this is between -2, because it's a negative, and -3, and it's going to be closer to the -2 than it is the -3. So I go to -2, I go a little bit below it, right, because we're in between this -3 and -2, a little bit below it, put a point there, and that's going to be where the negative square root of 5 is. Okay. The one nice thing about this process is by doing this, by putting them on the number line, I now automatically have them in order. Okay, they're now in order, which is going to help us with a problem like this, okay? Because we'll see these a lot on the Keystone and PSSA, where they want us to put them on the number line from least to greatest. Then they want us to put them on the number line, and then they want us to tell what they are from least to greatest. And as long as we put them on the number line, we'll basically already have them in least to greatest and can then list them out. So first off, let's kind of go down here in order. 3, that's an easy one. That's an integer. Put that right there. Okay, that one doesn't take much effort to do, so that one is 3. Next one, we have 5 halves. Let's go ahead and either think of this as a mixed number or as a decimal. 5 halves would be 2.5 or 2.5, so that's halfway in between 2 and 3. So I'll go here, halfway in between, put a point, and label as 5 halves. All right, so that's 2 numbers down. And let's erase this so we don't get confused about why this 2.5 is sitting there. All right. Next one, we have pi. Well, pi is an irrational number, meaning it goes on forever, doesn't have a pattern. But luckily, pi is one of those irrational numbers that a lot of us know from either prior math classes or just like pop culture. It shows up all the time. So we know that pi is approximately around 3.14. And that's a pretty simple approximation, not the best approximation, but it's good enough for what we're doing because, again, as you can see, in between these numbers, we don't have exact places. We're trying to estimate about where they are. So that's going to fall just a little bit above this 3. And again, I'll label that as pi around 3.14 And that's going to sit there. Next, when we have the square root of 6, again, we're going to kind of use that method I've talked about a couple times, where we're going to say, all right, where does it fall in between? What perfect squares? This one's going to fall in between 4 and 9, the square root of those two numbers, which in this case is going to be in between 2 and 3. It's going to be a little bit closer to 2 than it is to 3, okay, because 6 is a little bit closer to 4 than it is to 9, meaning it's going to be just a little bit under this 2.5. And that's where I'll go ahead and put the square root of 6. And then last but not least, we have 4.23. Well, we'll go 4. We'll go about a quarter of the way. And that's where we'll put 4.23. Again, let's go ahead and let's erase some of this extra work just so that you guys have a little bit easier time kind of seeing what these numbers are in order. Okay, we're going to have, if I have to put them in order, I can see what the order is now. It's going to be the square root of 6, then 5 halves, then 3, then pi, then 4.23. Okay, and I get that just by putting them on the number line, by basically comparing them to each other by doing this, all right? Again, a couple things to point out to you. Square root of 6, using those other perfect squares that I know to kind of do it. Again, if they allow you to have a calculator, like on the Keystone exam where they allow you to have a calculator, this becomes a lot easier. You can turn them into decimals and do it. But we want to make sure that whether we have a calculator or not, we can go ahead and do this by using some of these other methods of thinking about it, okay? Estimating what pi is, turning this into a decimal, knowing that 5 halves is 2.5. The square root of 6, using my perfect squares to kind of compare and get close to it. All right. And again, these do not have to be perfectly, this doesn't have to be perfectly in between the 2 and the 3, like, oh, it's exactly in the middle. We're kind of estimating a little bit, but we want to make sure that our estimates are pretty accurate so that we get that correct order for whoever was going to be looking at this. All right. So that's how we're going to put these numbers on the number line. Thank you all for watching.